difference between distance and displacement. So it seems like it might be common sense, but there's a little trick to it. So we'll start here with something that's probably the easier of the two concepts, and that's distance. And you already know this. Distance is just how far an object travels. Doesn't matter if they're traveling east, west, north, south, left, right. It's just how much they actually move. And we'll see this ant moving on the ruler. If he goes to the point here, he's moved 3 centimeters. His distance was 3 centimeters. Again, common sense, that's nothing new. If he starts at the 3 and walks his way back to the 0, guess what? He still went 3 centimeters for his distance. So again, direction doesn't matter. In the first picture, he walked 3 centimeters to the right. The next picture, 3 centimeters to the left, but it was the exact same distance because distance, again, just matters how far you move. In this picture, it's a little more confusing, but it's not really if you pay attention. At first, he walked 5 centimeters to the right, and then he walked 2 to the left. From 5 to 3 would be 2. So the total distance he walked was 7 because he walked 5 centimeters first, 2 centimeters the next time. Again, it doesn't matter right or left with distance. His total distance traveled was 7 centimeters. 5 to the right, 2 to the left. Just add the two numbers and you get his distance. Let's look at these two pictures. I'd pause it and see if you can determine the distance in picture 1 and 2. See if you're understanding this, and then I'll go over it here in a second. All right, 1 straightforward. He starts at 0, he goes to 5, so the distance was 5. In picture 2, it's not as obvious. He went 6 to get here, and then from 6 to 3, 6 minus 3 is 3. Now we add up the 3 he walked backwards, the 6 he walked forwards. 6 plus 3 would be 9. So his distance traveled in that second ruler was 9 centimeters. Go ahead and put that down in your notes. Press pause here to write your notes, and then unpause to go forward. All right, now the other big term of today is displacement. Displacement is the difference between where an object ends as compared to where they started. So the direction does matter now. So it 100% does depend on direction because displacement is your final position where you end up minus your initial position where you started. Fancy formula, delta, that triangle means change in distance. The change in displacement is the final distance minus the initial distance. But we do need to put directions. So you can have positive or negative direction. You can have north, south, east, and west direction. You can have angles, but you have to have something. You can't just say 3 centimeters anymore. You'd have to say positive 3, negative 3, 3 east, 3 west, whatever. So remember, our example that we did before of our distance was the ant walked 3 centimeters. Didn't matter which direction. But an example of displacement would be the ant walked 3 centimeters east. We've added the direction that he walked because the big difference with displacement is direction matters, and it's going to be where you end up compared to where you started. Sometimes the distance and displacement will be the same number, but they won't always be. So if you don't understand the difference, you will definitely make some mistakes. So here goes with our lovely little ant. And in this instance, his distance started at 0, went to 3, was 3 centimeters. His displacement, he moved 3. Notice here on the key, they're saying to the right is positive, so it's plus 3 centimeters. So the only difference here was the distance was included for displacement. In this case, he's walking to the left. He's starting at 3 and going to 0. So his distance is still 3 centimeters. He moved a total of 3, but his displacement now, since he's moving to the left, there is negative 3 centimeters. Again, displacement includes direction. So we always have to have a plus, minus, northeast, southwest, something telling us which way he went. Now here's one that gets a little tricky. We showed this one before. We said his distance was 5 to the right, 2 to the left. So his distance, he traveled a total of 7 centimeters. However, his displacement is 3. What? How does plus 3 make sense for his displacement? Well, we have to remember, displacement is where you end up compared to where you started. He started at 0, he ended at 3. So the total displacement was only 3 centimeters. He walked 7 as a distance, but his displacement was 3 because he only ended up 3 centimeters away from where he started. So that's another difference with displacement. Go ahead and pause just a little more to put in your note guide. Another example, here's displacement versus distance. An athlete runs around a track that's 100 meters long 3 times, and then he stops. So 1, 2, 3. What is the athlete's distance and displacement? Remember, distance doesn't matter about direction. So he ran 100 meters 3 times. So 100 plus 100 plus 100, his distance would be 300 meters. His displacement is where does he end up compared to where he started. We said he ran around once, twice, 3. So he ends where he started. Oops, sorry about that. Which gives him a displacement of 0. He ran a lot. He's probably tired, but his displacement is where did you end up compared to where you started? It's 0. He ends up at the exact same place he started. All right, a couple practice questions. Let's look at these. You'll see some of these later when you're doing your Kahoot. The way this bottom picture, I'm going to start with it, it's a little easier to understand, is when he starts, he's at A. He goes all the way to B at the 1 minute mark, back to 2, where C is for the 2 minute mark, and then D for the 3. So the distance, we've got to add it all up. The first distance was A to B here was 160. Then he went from 160 to 40 here. 160 minus 40 is 120. From there, he went from 40 to 120. So 120 minus 40 is 80. And that's where he ended. So we add all those up together. If you're good at math or use a calculator, that would be what here? 160, 280, 320? Nope, 360, sorry. I was not good at my mental math. So 360, assume these are meters, is his distance. His displacement is going to be a little easier because all we care about, let me just erase this, for displacement is where does he start compared to where he ends up. So his displacement is 120 because he started at the 0 mark, ended at the 120 mark. It doesn't matter that he was skiing back and forth, left and right. His displacement would be 120, and they give direction would be to the east. All right, let's start with the picture at the top now. Starting point, it says, is at 0. They first go to the left 2, and then they end up at positive 4. Oops. So, all right, distance. Simple, just add each step. 0 to 2 is 2. 2, negative 2, but we don't have negatives for distance. Negative 2 to 4 is 6 spots. So first he went 2 to the left, and then 6 to the right. So 2 plus 6 is 8. So a total of 8 centimeters is his distance. But once again, for displacement, all we care about, where do you start? Where do you end? So his displacement was 4 to the east. He moved 4 to the right, 4 to the east. Go ahead and put that in your notes. Pause if you need to. I'm going to move on here in a second. Pause to put that in your notes, and then you are all done and can go work on your Kahoot.